So I think I will have the first question to Dovydas. And what do you think are the greatest achievements of data science and software engineering so far? So we will start from the history and go to the future.
Well, it's an easy one, right? The greatest achievements of both of them. I want to maybe simplify the scope. Both software engineering was the great. I guess maybe a Linux kernel.
Who knows it?
It's pretty amazing, right? And so that's the software engineering part one. It's Linux is of course amazing thing, and so like the Kickstarter, I guess, of the whole open source, not the whole open source thing, but like a great like poster child for open source. What about data science? Hard to tell. I would say maybe AlexNet, the first convolutional neural network, the one which really brought deep learning to the forefront of like what's going on in machine learning. So it's hard to say like what are the most impressive technologies, because like obviously the ones which are developed today or like in the works at Google, Microsoft, Amazon, these are the greatest ones. Even like Laimonas says he's an expert in AWS. AWS is like again insane how great it is, how it changed everything. Serverless, it's again like such a great new revolution, which allows us not to care about the underlying infrastructure, but we really manage everything in the time of compute time, and almost really scale infinitely, almost infinitely right now. So I don't feel first of all qualified to give a definitive answer to this one, but at the same time I think like the ideas which I mentioned are great in my opinion.
Okay, Laimonas, maybe you have something to add.
Sure. Maybe let me start from the maybe software engineering part. What is the greatest achievement? I really do believe that the greatest achievement is actually the environment that we're in currently, and this environment allows us to basically deploy some solutions extremely fast. I mean, within minutes or hours, you can automate some piece of business process, deploy it to cloud, and it will become available instantly for the whole world. And again, as my colleague said, it will scale infinitely. So I think that this is the greatest achievement, the environment that we're in right now. For the data science part, I think I'll be a little bit more specific. I think that the greatest achievement would be probably deepfakes. Anyone knows deepfakes? They're pretty cool. They're pretty scary. And as they are now, they are at really baby steps right now, but I think they have a lot of potential disrupting the world. But yeah, I think that this should be one of the greatest achievements of data science.
Going further and I have a question for Tomas. You have been to the both worlds of this, and what do you think? What industries can still benefit from data science and software engineering, like industries and human beings, like a person itself, a civilian? So what these two can benefit?
Well, I don't have so much experience in software engineering. I did study that, but I think which industries could actually benefit from that would be the governmental institutions. That needs to be digitalized much more. In Lithuania, we have a lot of nice initiatives, which is super nice, but this could be improved much more. There are a lot of advancements in the health industry, which is really already good, but also could be improved. So with data science, you can solve a lot of different problems, like detecting cancer, early type of diseases, and yeah. So basically, more research in that area would be very beneficial, as from the industry perspective, but also on a personal level, because it would help us to live a longer life. Yeah, that's my
Thanks,
5
Thomas.
cents.
I will have same question to Lukas as well.
I want to reflect as well on those greatest things, maybe firstly, because I was thinking a lot on what makes software engineering so beautiful. So one thing for sure is, I guess one of the first softwares that were ever created are one of the most important ones, because everyone knows how it's hard to start things in generally. It's easier to start when you have a good background or like some generally like foundation. But when the first programs were created with assembly or even going even behind other languages, but that was the beauty of basically working with zeros and ones specifically and making it as abstraction level higher and higher. So that is one. And regarding data science, I guess generally GPU-based computing software is one of the greatest inventions that helped general data science to progress so fast. And Moore's law is not going anywhere in upcoming years, and we have problems with hardware. And it's crazy to see that even currently we see huge optimizations happening and increase of power and generally programs in speed and capabilities to process information. So that is proves how we humans can leverage exactly what we have now, not think about tremendous leaps, quantum leaps in the sense of computing, going to quantum computing, which is still something from science fiction yet. So those are reflections. And benefits for the future, I guess quite clear. Good reflection would be Paul Romer's, one of the Nobel Prize winners of 2018 idea. Generally, he got Nobel Prize for explaining how technology generally impacts economy, because in the past, generally in the past 20, 30 years, there was idea that 20% is correlated with materials like traditional economy, and there's like black box, which is technology. It's not clear how technology impacts the economy. And Paul Romer, 30 years ago, basically came up with idea explanation, which is really mathematically grounded, which explains that technology is basically the reason why economy is growing. 80% of all the growth is accounted because of technology. So I guess it answers the question. So what the impact of software engineering and data science is going to be 80% of our economy increase of coming years.
Thanks, Lukas, so much. The wind is also agreeing with you, I think. So which important problems do you think currently do not seem like ones that could be solved by neither software engineering or data science? What do you think, guys? Who wants to grab the mic for this? That's a tricky question. Tomas? Or Laimonas? Laimonas, okay, thank you.
Okay, I think the problem that I'm thinking right now is rather more like philosophical one. And I think that problem sounds like this: can programs have consciousness? This is what I'm really interested in, so that the answer would be, the question would be answered someday. I think it is impossible to answer it right now. It's really interesting what would future data scientists would tell me. I really hope that the answer is yes. But yeah, I think that this philosophical question is currently unanswered.
Dovydas, what do you think? Oh, Tomas, okay.
Yeah, I just wanted to say that, yeah, with the data science, there are a lot of problems that cannot be solved. It's because data science, you can build a model as good as you have data. So for some problems, you don't have enough data. So basically, then you cannot solve that problem. So that's...
Okay, Dovydas?
Yeah, I'll be an optimist here. I think everything is going to be solved. Or I guess there's always going to be new problems, but when they are going to be solved with computer science, data science, whatever with technology, I guess the technology is the underlying concept behind both of these. We have done that repeatedly for millions of years as humans, from the very simple, like stone axes to iPhones, GPT-3 right now. So we are going to increasingly do that. And if we are bringing philosophy here, so just wait until we develop AGI. Then you'll see what technology can do.
I guess a lot of things were said. So let's move to another question.
All the list checkpoints are here. Okay. Yeah, but the question is about the future. So we can see that technological advancement is so fast for the last 100+ years, and the society is not growing, developing that fast as the technology world is growing and developing. So what are the risks for the future from prevalence of data science as software engineering? So you will answer that.
Yeah, this is a good one. Generally, problems won't be technical ones. The main problems that we will face will be relatively human. Generally, like, I guess, how we interpret generally the new inventions, and generally social exclusion is going to be one of the hugest problems. I don't think that we will have technological problems. The bigger problems will come from political and socio-economical perspectives. So I guess our role here is as well to be educators in our surroundings and educate people about, how the technology and generally the juices of that enriches our environment, and how we should be focused on that, and specifically in younger generation, because we see a lot of influencers as one of the things, and YouTubers as one of their future careers, which is okay, but it should be about some kind of content, not about just being influencer because of the sake of influencer. So we need to bring the focus again on the core values here. So I guess it's not technically related to the data science, but generally how we won't be as close community, but will be as open community as possible to invite more people to understand science in the simplest language possible as well, because that is hard to interpret generally, but we can make it, TikTok for science, something like that, but more easily to comprehend. So that is my insight on that.
Yeah, I totally agree with Lukas that humans are the problem.
In short.
Yeah, technology is great, right? Humans are the bad part. I hope that the new AGI won't share this ideal with us. But in all seriousness, yeah, it's a very difficult question. It's even hard to have an opinion on that. I think I kind of want to reference to Ray Kurzweil, because he wrote the whole book about it, and I guess spent so much time on just specifically this idea of like nonlinear growth. And it seems to me that he's right, that we are living in this nonlinear growth period, or I guess we always have been. And I hope that we as a society, this will force us with like clear evidence of nonlinear growth will force us to like change our institutions, change our like way of like society as a whole, to adapt and live in this world that's changing in a geometric progression.
Yeah, I think the biggest issue that's coming up soon, as you said, it's not going to be a problem with the computation power, but as models grow much more complex and we also gather more data, so models usually now know more about us than we do. So basically, those inferences that models are making can be discriminating and maybe non-ethical sometimes. So it's going to be much more difficult to interpret those models and actually manage them in the correct way, so they're not discriminating people. So I think that's the problem.
Yeah, so as the last last one to answer, I had some time to think. I came up with maybe two more specific examples, two more specific risks that involve the prevalence of AI. I think everyone has heard the risk of unemployment, that people will start losing jobs to AI, and I don't think it is a real risk, because I would consider it as an industrial revolution that happened a few hundred years ago. What I mostly fear of is losing control over AI, and it doesn't need to be general AI. It can be a pretty dumb one that is good at something, is really good at something, like, I know, hacking the systems or whatever. And these, air quotes, simple AIs can fundamentally disrupt the world. So I'm mostly fearful of that one, losing control.
Okay, so scary stuff, yeah, guys. Because we are coming back to the stupid humans once again, and there's humans next to the technologies, and we have some of the questions related to that. I really want to ask Lukas or Dovydas the first question, and I think it's very related to of how to say reskilling or requalification, because I think it's very important for our community and new members who are coming to our community as well for the future. So what do you think? Can anyone become a data scientist? If yes, why? If no, why not?
I guess Dovydas is in better position to answer that.
Since I'm in the middle, of course, it's a much easier position. Yeah, I think absolutely yes. Anybody can become a data scientist. Data science, I mean, it's not some magical field. It's not. You don't have to be like super smart, like top 1% in the world. It's just a job like any other jobs. It is very valuable for the companies which do use data, which are like almost all companies, or at least it's gonna be almost all companies in the future, because the ones that are not using data are gonna die off. They are going to need a lot of data scientists. They are going to need, if they want to develop like competing products, they have to have machine learning based features. There is no question about it in my mind. It's impossible to think that like someday Google is just gonna like let go and say, hey, let's remove all of the like machine learning based features because they don't add any value. They have been doing that for like more than 10 years now, and they have been doing that increasingly fast in the last couple of years, spending enormous resources on research, and these are the largest companies in the world which are mostly invested in ML features. What does this imply? That everybody's gonna need to catch up. How they gonna do that? They will need data scientists. So in short, lots of demand for data science. That means a lot of things, lots of market for Turing to prepare students to become data scientists, because they'll have like employees waiting for them.
Tomas, can I add to this question as well?
Yeah.
What does it take to be a good data scientist? And
Yeah, so first of all, I just wanted to maybe define what is data scientist. So it's a person, someone who has domain knowledge, who knows how to program, and has mathematical and statistical knowledge. And by using that, he gets insights from the data. So can anyone become a data scientist? I mean, I guess so. I mean, you all have some specific domains that you're really interested in, so you can be good at that. We all learn some mathematics at school, so we need to know a little bit more. And programming is really fun. I think it's like a game, so everyone can also learn that. So yeah, by combining those three components, you can become a data scientist. Not sure how good, but with time you would become better. I mean, it's all practice, and you just have to be passionate and really curious. That's the most important qualities for data science. And what was another question?
okay, I will add the question: will there ever be too many data scientists? What do you think?
No, actually, I mean, data science also helps in real life, right? Analyzing daily situations, raising hypotheses, and trying to see if that, proving that hypothesis, improves your life. So I don't know. I mean, I think being data scientist helps in daily life. So I mean, and there can be unlimited amount of data scientists. I don't know. I think it's a useful profession.
Yeah, so from just several hard numbers regarding data science demand and supply. This year, there's approximately 3 million postings for data science jobs, going to be data science jobs. And last year, only in Europe, there was about 400,000 open positions in data science area. So not specific data scientists, machine learning engineers, data analysts including. So those are from hard numbers. The demand is increasing faster than software engineering. So just have that in mind, and it's hard to find those specialists. Of course, you can say, yeah, they need more mids and seniors than juniors. There is true of that, but as well, companies with more mature data science teams, they hire a lot of juniors as well. So that's always a chicken egg problem for every category of software engineering, computer science, I would say.
As a moderator, I can answer also one question. why there are no women on this panel. Guys, consider me. No, I will just kidding. Every we reached out to a lot of women in the industry, and they're all in vacation, so it's a summertime. Come on, guys, it's very normal answer, I think. Men are working, you see. No, they're. Next time, definitely, we will have more women in the panel. Okay, how computational neuroscience could affect data science and development of general AI? Is brain just too complicated to model? Dovydas, I think it's your question.
Yeah, again, as the panel's optimist, I feel that we are going to solve brain. It's hard to tell when, but I mean, like we have solved these simple worms, like I don't remember exactly the name of the worm which we fully modeled. It's very, very hard, but at some point, you know, with scaling, again, Moore's law, more software, more hardware, larger data centers, larger pool of experts. Like again, this one is like super important. We have like much a small community, comparatively small community of data science professionals that we just don't have enough, like that much capacity for people who are actually doing this. So with more people, more technology, we are definitely gonna tackle that. And my personal hope is that we are gonna do that in this century.
Okay, thank you so much. Maybe it's to switch up, and maybe we have hands from the audience who have questions. Or do you just put all these questions here? Okay, thank you. Yeah, very techy, guys. To be successful, what are the main differences in interpersonal skills? What a data scientist should have against those that have software engineers should have? So comparing those two, and what skills are required in both sides? Laimonas.
Yeah, so data scientist versus software engineer, right? I think the biggest difference between these two titles is that data scientists are actually scientists, and they are motivated by dedication. They are motivated by science going further, and software engineers are rather mathematical thinkers, problem solvers. But data scientists are more looking, I think, more to the future. I think that would be the biggest difference.
Yeah, I think the negotiation skills and presentation skills are very important for data scientists. Because you kind of, like, from my personal experience, you kind of have to drive the whole product in a team. So basically you define where the team is moving with the product manager, because you raise the hypothesis, you see what's feasible, and where, what should the company be developing, the team. So you have to actually convince the team that this is feasible, this is viable, and this is important for business. You have to present it in a proper way. And yeah, that's how you define the roadmap for the team. So I think that's a very big difference from actually when you're working as a software engineer, where things are kind of more well defined with the requirements, and it's a less specified space, let's say.
Yeah, there was some question, I don't find it here, but I think I've read it, that data scientists are poor software engineers. Is it true or false?
Depends on how much money they have. Otherwise, if they are they might be rich software engineers. Now, I understand the question. Just kidding. They are weaker programmers, like almost always. But again, software engineers are weaker designers than designers. So it's just a different job. They have to have, like, it's impossible to be as skilled in programming and like architecting your whatever solution in software engineering domain as a data scientist. And that should be obvious. It's just programming is the tool which increasingly many positions are using. I mean, like in some cases, product managers, accountants are also using programming, maybe like as an Excel, like add-ons, maybe sometimes in Python or Spark, but programming is increasingly not only just software developers' tool, it's increasingly used by other professions.
So yeah, data science is also very broad. So it depends where you work, because if you put machine learning into data science, then you do much more software engineering and much more programming, because you have to create custom models and you have to create classes, functions, and etc. But if you do data analysis part, like you work more like a data analyst in the company, then you just maybe play around with dashboards and these type of things. And if this is your daily job, obviously you're going to be much worse in programming. So it really depends on which direction you go, because data scientist is also quite broad definition.
That's very true. So, okay, I think a bit somebody is sleeping in the first row. No? Okay. A bit heads up for the audience. So, my question from you guys, what's your background? Do you have non-engineering background? It's not related to data science, software engineer, like history, philosophy, like human, how to say, fundamental sciences. Who has some kind of these ones? Oh, half of them.
Perfect.
Yeah, humanities, so-called humanities or social sciences. Some of them, okay. At least half of them. Those who have like hardcore engineering, not software engineering, hardcore engineering, mechanical engineering, or something, civil engineering. This is something, some sort. Those who have computer science degrees. Not that many. Some of them. So not actually, only few of those people in the audience have. So that's an interesting, I think, our community as well, because you can show that you can switch to the new field in life, I think. Yeah. Okay, so we will go to the more advanced questions, and we have some of those. With advancement of reinforcement learning and AR, data science as a poor role not in danger as a role for the future?
So first of all, reinforcement learning is part of data science. So I don't know why.
Well, that's the question was, but okay. But if data science role in danger for the future because AR and it's growing. What do you think? Dovydas is the futurist.
Yeah, it's what's right. It is part of data science, reinforcement learning. It's not part of statistics, and I guess like a lot of people like, hey, so what's this machine learning thing about? Like, what's the difference between that and statistics? One of the differences, reinforcement learning is not in statistics. AR, that's I guess an odd one. But like I want to focus on the last part of the question, which was like, is data science as a pure field in danger? I really hope that it is. I think that like calling everybody that like touches data a data scientist is bad. It's like the same thing as they want to silence me, but I keep speaking. If something happens to me, you know, like the data scientist
AI.
got me.
AI.
Yeah, so I hope it's like I hope that in 10 years we don't have like a title data scientist. The same thing that we don't have like programmer today. Like it would be weird if somebody like you get a job as a programmer. Like what? Am I back-ender, front-ender? Like, well, what do you do there? Yeah, you just do computers. So I hope that I hope that we'll specialize and we'll be like maybe, you know, data engineers, analytics engineers, machine learning engineers. Maybe they'll have like machine or like data science generalists, but ideally that should be like a separate role with very clear like, hey, you are gonna be like a detective in a company. You're gonna like find out stuff, and it's gonna be hard. And you don't know like what your job is. You have to figure it out yourself. But like somebody working on a computer vision model just to make the best face detector in the world, or I guess fastest or whatever. They don't want to be like just called data scientists. Then the same title also implies that you play with dashboards all day. It's like two super different jobs, and none of like there is no right answer right now. So in short, I hope it's gonna die. I hope it's gonna be replaced by much more specialized roles. And my hope for the future is based on evidence that companies are increasingly doing that right now. I recently checked how many different titles Amazon is using for various types of data scientists. I think I counted about 12. So it's Amazon is, I guess, leading the way with very specialized job titles, and it's very clear what you're going to do.
Thanks so much.
Can I also add? Yeah, so very well said. I do agree, and I see a clear pattern that titles like software engineer and data scientists will indeed be gone. Not sure when, maybe after 10 years or 15, but we see a really clear trend in every single industry out there in the world that is starting to implement IT processes and dual specialities like someone like chemist plus IT are becoming more and more prominent. So I think this is a really clear trend, and in 10, 15, 20 years we will have these merged specialities where if you are a scientist, if you are a chemist, biologist, you are also an IT guy, you know how to program basic stuff.
Well, that's definitely true. I had to learn how to program when I was in engineering studying. Okay, the last 3 questions, and we will wrap up our discussion. I think there was, no, not this one. Oh, there are too many questions. Okay, so maybe I will just very personal question for you guys. And what do you think? What are the biggest mistakes do usually data scientists do in their careers? And maybe you know some of them.
I guess I will pass this one. I'm not
Question, like I remember there was a question like very similar but about learning data scientists.
Yeah, so we can merge that.
I would maybe want to do learning first, because like in careers, yeah, you go on vacation for a year in Bali. That's a pretty big mistake for your career advancement. But for learning, the mistakes are different, and typically I see people like I hate it, by the way, like this is why I'm here actually, because I really hate people not getting how to learn this thing, I guess efficiently or at all. People they don't know the path to the successful outcome. They have some successful outcomes in mind, like getting a job, starting their own startup, but then they have no idea how to get there. And it's like a maze there. You can spend, I don't know, 5 years learning about reinforcement learning, and then realize that, yeah, like this field is not very applicable. I mean, like it's more research at this point. And yeah, you just wasted like all of these years. It won't help you to get a job as a data analyst or a data scientist. The same thing applies with like mathematics, statistics, probability. Great fields, like super interesting. Probabilities are like one of the most interesting things for me personally. But like, do you really have to be like a very strong expert to be a data scientist? Typically, no. Typically, you have to have a mix of basics, and these basics are gonna be enough for you to get a job. And then depending on what you do in your day-to-day job, you'll continue learning. But then your learning will be driven by your employer. And you pretty much you're going to learn what's valuable in that company. So the biggest mistake is not optimizing your path towards getting hired. And if you do that, then you're in a very, very sweet spot to actually become an expert or professional data scientist.
I'll add a quick one. So I think the biggest mistake also that I made was that when you start this in this field, you want to do all the cool stuff, the deep learning and all the like modeling, and at university they're always saying you're gonna do 80% of the time preparing the data, and you're like, oh, this is bullshit. No, it's not gonna happen. But at the end, you actually do that, and you don't use these very fancy models, not on daily basis. Sometimes you use something very simple, but then a lot of time you spend on actually, preparing the data, generating nice features and stuff. So the real hustle isn't there, and modeling doesn't add that much as you would actually think when you start. So you study deep learning and all those fancy things, spend so much time, energy, but then at the end you don't use it that much. So focusing on these essential things is more important than doing all the fancy stuff.
Continuing with this, what you mentioned, Laimonas, what advice would you give to a future data scientist?
What advice? Get your expectations straight, I guess. Yeah, I think continuing on that, maybe one mistake, the biggest mistake that not necessarily data scientists, but also software engineers and other professions do is they sometimes have overhyped expectations. For example, people think that hackers do all these fancy things like in the movies. Spoiler alert, it's not true. So this also holds true in software engineering and data science. They're not like in movies. So keep that in mind.
We wish, but it's not. I wish not. Okay, I think the last question for everybody, and we are talking about the future, of course. So, what developments incites you for most about the future of either software engineering or data science, and what advice or lesson or congrat would you give to the data scientists here?
I guess there's too many things that excite us generally in this 21st century. But generally, I guess, and specifically speaking, I'm really excited about the possibility and the presence in the future, speaking about that, when we will be hired by not having PhDs, but our real performance, which is still absent. And if you look to our job market currently, it's so biased and it's not disrupted for many years. And if you know kind of employer personally, you will land a job. Nevertheless, that there could be some guy that knows stuff more precisely and more in depth. So I'm really excited about that opportunity that finally maybe we have the solution here to be high by our performance, to have some kind of meritocracy here happening. So that's from my end.
Yeah, so in my opinion, what I'm excited about, actually products. I think that products today are pretty bad. I hope they'll get better. By products, I mean like everything from hardware products to software products. I like what some companies are doing, like Tesla is trying to make cars better. That's a very noble goal. I hope they'll succeed. I would like to see cars that drive themselves. I like brave companies that go all in and hey, we are going to make this like huge leap in how this product category is even defined. So that's what I can't wait in the future, having smarter iPhones and better cars. My advice for the future, I guess learning is like universally good thing. Like whatever you learn is going to be valuable. Like if you learn data science, there is no way that you're not going to use it. In any role, in any domain, in any company, this is going to be valuable for you. So I hope that, and I hope that it's going to be valuable for you as data scientists if you work as data scientists.
Okay, so maybe for me, the most exciting investment looking into the future is the cloud. Not necessarily AWS, of course, just the cloud and digitalization of our lives. What I see again is quite a clear trend that our lives are becoming more and more digital. So maybe the biggest thing that excites me is that at one point of time, maybe our lives just be completely in cloud. not physical, but rather digital.
Yeah, when I was listening to you, I thought of 3 really cool companies or products. And actually one connects to your idea is the Neuralink, the augmented brain that Elon Musk is developing. The other thing is Waymo is really cool, 'cause self-driving. So really curious to see when it's going to be in Lithuania. And another one, which one did I have? OpenAI and the protein folding. What? Vinted, of course. But yeah, I just wanted to say that you shouldn't stop being curious about everything about the world. I mean, that's the most important quality for data scientists, to be curious about the world. And also, it's all about incremental steps. I mean, Netflix took 20 years to build their recommendation engine, so it's all about incremental steps. And look where they are now.
You're now in the bubble of Netflix, the same rom-coms you're watching, yeah? Okay, thank you so much for the panelists. Warm applause to them.